Thank you everyone for coming this afternoon. I do need to apologize in advance ever so slightly because I have a bit of a cold. Unfortunately, 1-year-olds and 4-year-olds do not understand social distancing, and I have therefore managed to pick up a bug from them. No cough, no fever, but if I do go on mute or stop my video for a minute, you know what's happening. I'll just need to take a little break. I promise you I will be back. So I'm Hannah Foxwell. I'm the Director for Platform Services at VMware Pivotal Labs. And I'm going to be talking today about SRE, Site Reliability Engineering, but most importantly, what it means for the people on your team who are supporting production systems. So, I'm asking the question, is Site Reliability Engineering good for you? So, a brief kind of history of SRE is that it was a set of practices and roles that were born within Google. And Google published the SRE book on O'Reilly in 2016. And, it created quite a movement within our industry. It was fantastic at that time to get an insight of how Google runs their systems and their infrastructure at such massive scale so successfully. But this is what I heard in 2016. You don't need SRE unless you're the size of Google. So at the time, I more or less ignored the topic. I didn't read the book. I didn't really get into it. And then I saw a couple of things happening. First of all, there was the DevOps movement, and a lot of the sysadmins and operators within the businesses that I was working with were being rebranded. They were being rebranded as DevOps engineers, as well as the operations work that they were doing previously. They were starting to take on automation, CI/CD, infrastructure as code type things. Those people got rebranded around the 2016, 2017 timeframe, and they started to become site reliability engineers. And you know what? I was like, I didn't really understand SRE at the time, but I'm a bit of a traditionalist, and I don't really believe that DevOps is a job title. I believe it's a movement and a set of practices. So naming things is hard, and I was pretty okay with the fact that the DevOps engineers were being rebranded to site reliability engineers, because that made more sense to me. That made sense a lot more than a DevOps engineer. And so for years, I didn't really do much about SRE until I saw this dashboard. So what this is a dashboard of PagerDuty's operations health management product. And what it shows is essentially the health score for the team who were holding the pager at the time for the CloudOps service within Pivotal, as it was then. And what you can see here is a really striking improvement from the beginning of 2017 to the end. They start off with an incredibly low health score, and the health score is derived from things like how many incidents were there, how many incidents were out of hours, how many incidents disrupted someone's sleep or their evening time, how many were what was the resolution time for them, and how many of them were false alarms actually. And so this was a really interesting graph at the time. And I had just started at Pivotal, and I was like, okay, what did you do? Results. What did you do to improve your health so dramatically? What did you do to improve your reaction and resolution times within all of these different incidents that were happening at the time? And it turns out what they did was they adopted SRE practices within their team. Okay, SRE, you have my attention now. I'm going to go and read this book. I'm going to find out more about these practices that have transformed this team that I'm working alongside now from a really unhealthy state where they were being regularly paged during the night, out of hours, for a service that was perceived to be quite flaky and quite brittle. So I thought maybe there is something to this SRE thing. To give you a little bit more context about why this was so interesting to me is that I've been involved in the human ops community since it was created by Server Density back in 2016. And human ops was a community that was created to promote sustainable and healthier working practices in operations. Sleep deprivation and stress, alert fatigue, they can all have really serious impacts on your health. And it wasn't a conversation that was happening enough in technology at the time. So human ops was created to promote better practices around that. One of the tenets of human ops is that the well-being of human operators impacts the reliability of systems. And it works in reverse as well. A very unreliable, flaky system will impact the health of the human operators who are holding the pager for that system. The human ops community was created to share and promote better, more sustainable practices. And we want to learn from the people who are doing it well. And so that's why I started to look into SRE. Today, what I'm going to do is I'm going to talk through some of the basic principles of SRE, but through a human lens. I'll focus on the health of the team, not necessarily the health of the systems that they support. There is a huge amount of content on SRE. The original book published in 2016 was followed up with further publications, the Site Reliability Workbook and Seeking SRE in 2018. There are new books that have been published on how to define good service level indicators, service level objectives. There are conferences dedicated to the subject. There's a huge amount of content here, but this is going to be a very entry-level talk today about what I consider to be the fundamental differences between the SRE approach and a traditional approach to operations. So Ben Traynor, who was the founder of Google's SRE team, defined SRE as the thing that happens when a software engineer is tasked with what used to be called operations. The fundamental practices of Google's SRE are really about balancing change and reliability. How do we move fast and how do we maintain stability? And how do we do that whilst maintaining the health and well-being of our teams? We are genuinely going through an evolution in operations. We need to adapt to running applications and platforms and infrastructure in a really software-defined, software-enabled way. We need to adapt our businesses to be online. And this year, 2020, has really seen an enormous shift away from traditional high street modes of delivering services to customer to pure online only businesses. The role that technology plays in today's society is enormous compared to what it was just maybe 5 or 10 years ago. And Google have been one of the leading companies in adapting to this new world and doing it really well. So it's important to learn from some of the lessons that they've taken along the way. In essence, SRE promotes the idea that failure is normal. In any system of any reasonable complexity, we should be prepared to deal with failure. We need to change our focus in our traditional mindset of being afraid of failure and focusing on purely preventative measures to also investing and spending time preparing and being ready for when failure inevitably happens. On the flip side of this, we also have to agree that reliability is fundamental. You're not going to be delighting your users with new features if your product is totally unavailable or if it's too slow to be usable. But we do need to ship new features. We do need to innovate as quickly as possible. We do need to meet the evolving demands of our users. The velocity of delivery and the reliability of the software and the platform you run it on will impact your business. So how do we reconcile these opposing aims? We need a way to negotiate what level of failure is acceptable, and we need to agree how much reliability is truly necessary to deliver the service that we're delivering. Nicole Forsgren and the team at Dora have been looking at data around DevOps since 2014. And they found that when they measured the performance of the highest performers in this space, there was no trade-off between improving the performance and achieving higher levels of quality and stability. Higher performers do better at all of these measures. The highest performers were shipping software faster, more reliably, and not impacting on the stability of the systems that they were shipping. So I'm going to start with the basics, as I consider them, of SRE, which is SLIs, which is service level indicators, SLOs, service level objectives, and error budgets. So service level indicators, these need to be unambiguous, user-centric metrics that you measure to give you a read on whether or not you are providing the service that you need to be with your software product. For example, is your homepage accessible? And does it load in a reasonable time? It's always very tempting to set SLIs for underlying services, but remember, you should always focus on the user and what the business impact is of a failure of that part of the service. So when you're thinking about defining your first service level indicator for whatever product, whatever software, whatever application or platform or infrastructure you're running, like, what do you need to think about to set a good SLI? To start with, it probably needs to be opaque and black box. You need to be able to somehow replicate the experience that your end user is having of that system at that time. That's the only way you can really know whether your user is impacted by a problem. It needs to be very specific. You need to define it in a way such that you can automate the measurement of it. It shouldn't be subjective. It shouldn't be woolly, whether it's a yes or a no. Am I delivering what our user needs? It needs to be representative of some user value. A good SLI will represent the most critical aspects of a user's experience. You know, you won't necessarily want to measure everything that your product does. You want to be able to take a cross-section of the jobs that your user wants to achieve with your software, and you want to measure that those users can do what they need to do. And also, it's a good test for your SLI is whether or not it's architecture agnostic. Could you change the underlying infrastructure and your SLI will still be valid? Could you re-architect away from a monolith to microservices, for example, while still delivering the same service to your users? If you can do those things and the SLI is still valid, then chances are you're onto something that's the right thing to do. It's very tempting when we talk about metrics and systems to actually pick your favorite system metric to measure, but service level indicators are really user-centric metrics. This is about whether your user can achieve what they need to achieve. Next, I'll talk about service level objectives. So a service level objective is essentially your target for that SLI. And it's never 100%. Like I said earlier, one of the fundamental pillars of SRE is that failure is normal. Failure is to be expected. Even if it's only a very, very, very tiny amount of failure, we need to be able to measure it. Not even the internet provided through your ISP is 100% available all of the time. There are service interruptions in that. So the perceived reliability of your service will always be somehow interrupted by the interfaces that sit and the networks that sit in between your user's device and your and your hardware. So there is an element of perceived degradation of service that you cannot control. And the very, very, very small amount of failure that you introduce into the system on top of that may be negligible compared to their experience. So it's important to have realistic and reasonable conversations about failure when defining your SLO. And again, an SLO should be about the value of your service to your user and to your business. So when you think about SLOs, think about the business value of it. What are the objectives that you're trying to meet with this service, and how does your service need to support those? Is it defensible? When you say that your SLO is 3 nines, for example, 99.9%, do we agree that this is the right number? Can you articulate why it's not higher and why it's not lower than that? It should absolutely represent user value in the same way that an SLI does. But this is more about the user's expectation. Does your user expect your service to respond in a timely way? Does your user expect it to be available 24/7? How do we know that our users are happy with the reliability of this service that we're providing? And also you need to think about, whether you're doing enough to keep them happy. If you miss your objective, do you know that you've impacted your users? And if you miss your objective, have you impacted your business? Now, it should be, excuse me, it should be an easy, if you've defined your SLI correctly and you've set your SLO at a reasonable level, it should be an easy yes/no answer. And if it's not, maybe you need to challenge yourself and iterate on it more. Do some thought experiments. What if our SLO was higher? What would it mean? What would it cost? And what would the benefits be? If your objective is lower and you accept lower reliability, again, what's the degradation in that customer's experience and what is the potential impact to your business? This is basically a happiness test. And you need to find that sweet spot where your users are happy and you've spent the least amount of money achieving it. Excuse me. So I'll talk about an error budget next. So your error budget is essentially the inverse of your service level objective. It's the very, very small amount of failure that you believe will be acceptable to your users. So for example, if your SLO is 4 nines, 99.99%, then you're actually allowed to fail 0.01% of the time. If your website is down, but you're still within your error budget, then you're doing great. It's very tempting in a very traditional mindset to view every single outage as a disaster and something that must be absolutely avoided. But having this concept of an error budget means that you have an understanding of what is acceptable failure and what is not. If you exceed your error budget, then you know that you need to do something differently. You know that you have not met your users' expectations and that you are not delivering what you need to for the business. You need to invest in extra reliability, and you need to maybe change your immediate plans to maybe take a few less risks until your service reaches a point of stability again. The error budget is a way to have more meaningful conversations about the reliability your users expect and to negotiate that balance between change and reliability and availability. It's a really big shift from what people do a lot of the time today. Any outage is seen as a disaster. All outages are treated the same. And also, not every outage is considered to be a real problem if it was caused by the system or someone outside of your team. But your user doesn't care about that. Your user only cares that the service was down and that their needs were not met by whatever that product was. So when we're measuring the error budget, we really have to be close to the users, and we have to do something differently to restore service and to get back get back up to the availability and reliability levels that they expect. So if 100% isn't your target, what is? How do you decide what's right for your service? This is where it's useful to start talking about your error budget in terms of time. We've said that your error budget is the inverse of your SLO, and it's the very, very small amount of failure that you can accept. For example, if your SLO is 3 nines, that means that your error budget, if we quantify it in terms of minutes, is roughly 40 minutes every month of acceptable failure. And I think when you're starting out with error budgets, time is a really good metric to use, because time is something that everyone understands and it's very easy to reason about. It's not so easy to reason about error messages and error codes and the appropriate thresholds for the number of errors that are acceptable. It's very difficult to perceive the extra investment that would be needed if you can't reason about your error budget in those ways. But it's very easy to reason about time. If you look at 4 nines, 99.99%, you're down to a 4-minute error budget per month. 4 minutes isn't really enough for an engineer holding a pager to receive a page, respond to a page, open their laptop, log in, and start triaging an issue. So immediately you can start to understand the amount of additional resilience, automated failover, active kind of infrastructure setup that you might need to put in place to get to a point where the majority of issues can be resolved automatically without any human intervention, without anyone having to pick up a page and do something themselves. So these, excuse me, these 3 concepts, SLIs, SLOs, and error budgets, all come together to give us a language to balance change with reliability, to balance things that may be risks, and change is usually a risk to a system, and the fundamental necessity for that system to be available and stable for the users. So the economics of your investment in reliability is something that is enabled by setting your SLIs and SLOs correctly. As I sort of alluded to, there's an exponential increase in cost the more and more availability that you need. You know, if you think about I think about 4 nines having about 4 minutes of acceptable failure every month, and the amount of automation and engineering and resiliency and redundancy that you would have to build into your system to mitigate any risk of any human intervention in the result of a failure, the cost starts to add up very, very rapidly. We also have a situation of diminishing returns. As your reliability increases, so does the likelihood that anyone noticed decrease. The difference between a 20-second outage and a 30-second outage is going to be negligible. Are your users really going to be impacted by this problem? And is the business impact of that user impact, does it justify the extra investment that you would need to achieve it from an architecture and a resiliency point of view? There's also this other line on the graph, which is the likelihood that anybody cares. So yes, like people may notice that disruption, but what's the actual impact of this? Is this really brand damaging, or is it just a glitch? Will they come back later to use your service? So that is an even lower probability. So taking these things into account, you can really have a think about what the correct level of investment is for your service based on the impact of any service interruption. And as I said earlier, there are ways to achieve each level of reliability. So for example, at 2 nines, you've got an error budget of over 6 hours. Like you don't even need really robust monitoring at that point. 6 hours, you should be able to manually inspect your system or be alerted via an end user complaint about availability. And that should be sufficient for you to stay within your error budget. When we get up to 3 nines and we're looking at around 40 minutes of error budget, then you need to probably have some comprehensive monitoring in place, 24/7 on-call processes, and you also probably want to have some good run books that you could use to make sure that you respond to each incident in a timely way, a timely but manual way. As we get up to 4 nines, we're down to 4 minutes of error budget. And this is going to require automated rollback of changes, detection of failed changes and automatic rollback. And you really want to be limiting at this point any human interaction in that process, because a human simply cannot troubleshoot an issue in less than 4 minutes generally. And then, we get up to 5 nines and we're really talking about very, very high levels of resilience engineering, making sure that your system can survive or gracefully degrade in multiple complex failure scenarios. So if you take nothing else away from this talk, I think it would be these 3 things. Set your service level objectives realistically based on the amount you want to invest in reliability, because you're not going to be able to achieve high levels of availability without that automation. Measure user-centric service level indicators for your products. Make sure that you understand unambiguously whether a user is impacted or not by an outage, so that there's no debate about the service interruption that occurred. And also enforce your error budgets. If you've used up all of your error budgets, then you need to rein it in. You need to be more risk averse. But if you haven't used up all your error budget, you can afford to take a few more risks with your system and know that you're within the sort of acceptable range for the users, and you won't be impacting your business inadvertently if you were to push a failed change at that point. Greg Thomas said that the only way to begin speaking a new language is to begin speaking it badly. And I think that this is incredibly true for these types of concepts. Changing the language around failure in your organization, accepting that an error budget exists and that a small amount of failure is acceptable, is a real shift for some people. Setting SLIs and SLOs won't be easy, but you'll learn through the experience and you'll be able to improve them over time. And then you'll need to manage your error budget on a continuous basis. You might want to do a rolling 28-day average of the amount of error budget that you're using. And these things, they can't just stay within the domain of IT. They need to be understood by your whole organization. It needs to be part of your shared vocabulary so that a business user understands why you can't ship the change that you were planning to ship, because it immediately followed a significant service interruption. And you need to protect the reliability of your service for your users. And you all understand the shared goals around reliability there. One of the first things that I would recommend is just sharing this as a vocabulary around your organization. You might want to incubate these practices within your engineering, within your ops team first, but eventually you do need to introduce everyone to the concept of error budget, so that when you're measuring that success or failure, it is within the context of an acceptable amount of failure every single time. It also means that you can have more meaningful conversations about investment in reliability. You can use your SLO and error budget data as reasons to spend more money on resilience, to invest in additional engineers, and to demonstrate the impact that it has on users and your business through the SLIs that you set. So what happens when you first set out on this journey is that you'll set some SLIs and you'll set some SLOs, and you may never have measured the reliability of your service in this way from a user's point of view before. And oh no, it turns out that you're not as reliable as you thought you were, and you're not as reliable as you need to be. And that's okay. That happens to a lot of teams. And what I would say in this situation is set a realistic SLO for what you can achieve right now. Use that data to ensure that you invest in more reliability, and set an aspirational SLO so that you know where you're tracking against where you are right now with your current system and architecture, and also where you want to be, your aspirational goal. This is what we think our users need, and we're going to invest in reliability to get us there. However, overachieving on your SLO is less okay. If your target is 3 nines and you actually achieve 5 nines, it's not necessarily a good thing, because it means that you're missing opportunities. You're either missing opportunities to deliver software at a higher velocity, accept more risk into the system in order to move faster and iterate quicker, get faster feedback from your users. It might mean that you have redundant infrastructure and that you're over-provisioned, which is not only wasted time and money, but it probably means that you've got some over-engineering in your platform and in your architecture as well. And when you over-engineer a solution, that's going to cost you more money long-term as well. You want to make sure your platform is as simple as possible for the needs of your business right now, and then improve it over time. This is where folks in your business can really become much more engaged in this conversation about SRE, because it means that you're making a commitment not to overinvest, not to overspend on reliability. You can have a conversation about what money you need and what investment you need to get to high levels of availability. But what you're also doing is you're saying, we've decided that this is enough and we will not go any higher. And then you can reinvest that money that you may have wasted into things that can really drive your business forward. You don't want to waste money on excessive amounts of reliability and miss opportunities to repurpose those funds on something that could have really helped your business or your team. Next, I want to talk about psychological safety. We've talked about SLIs, SLOs, and error budgets at a high level. So I want to talk now about the people in the team who are implementing these practices. Psychological safety is an important factor in team effectiveness. And there's 2 definitions I want to share with you. Psychological safety is a shared belief that the team is safe for interpersonal risk-taking. And this one, which I prefer, psychological safety is a belief that one will not be punished or humiliated for speaking up with ideas, questions, concerns, or mistakes. And in the research that Amy Edmondson did around psychological safety, in a medical context, what she found was that when teams were measured on psychological safety, error rates, and team performance, it was the teams with higher psychological safety that had higher error rates, which seems logical. If you feel safe in your environment, if you feel free to speak up when you've made an error, that you won't be reprimanded or punished for that, you're going to see more honesty amongst amongst people about the mistakes that they've made. What we also saw, which is somewhat counterintuitive, is that higher error rates, more reported incidents of mistakes, correlated to higher team performance. And when we're talking about this in a medical context, which is where the research was done, that essentially means better patient outcomes. The higher psychological safety created an environment for higher performance because people were able to talk more openly about the mistakes that they were made. They were more able to learn from their own mistakes and from the mistakes of others. And as I said, in a medical context, this is really fundamental. This means better practices and more lives saved. But within a technology context, the same has been shown. Google did a project a few years ago called Project Aristotle, where they were looking at the key differentiators between teams who were very, very high performing and teams that were not. They looked at all kinds of factors. Were they co-located? What tools did they use? What was the makeup of the team? What was the team structure? And actually, Project Aristotle found the same thing. It found that the major differentiating factor between the highest performing teams was this aspect of team psychological safety. An environment where people felt like they would not be reprimanded or punished for their mistakes, and where they could talk openly about what they'd learned from those mistakes, creating an environment where everyone can learn from errors and learn from each other. And so I've been talking about error budgets, and I've been talking about psychological safety and how that can improve team performance by creating an environment where people can talk about their mistakes. And so I have a hypothesis. We know that psychological safety has been shown to improve the innovation within teams, increase learning within teams, and boost employee engagement. We also know that one of the key principles behind SRE practices is that an amount of failure is normal and to be expected. And all of our processes and practices are designed around that as a fundamental principle. So this is my hypothesis. I really think that SRE practices can transform teams by improving their psychological safety, giving them a language to talk about failure in an open way and in a way that is acceptable, a way to advocate for more investment in reliability when it's needed, and a way to measure the satisfaction of their users in an unambiguous and not emotive way, as it may be at the moment. The next concept I want to talk about is toil. So toil is defined in SRE as manual, repetitive work. It's the type of work that could be automated away. It's generally tactical. It doesn't have any enduring value. Do you need to reboot something? Do you need to run a script on a regular basis? What are those aspects of your job that are manual and necessary, but don't really add a lot of value? They don't move the needle. When I spent a week with the Cloud Ops team back in Pivotal, it was really great to see how they'd adopted the word toil as part of their language. Every task that they had on their backlog, you could see them sort of analyzing it, and you'd hear things like, oh, this one feels a bit toily. Maybe we should look at automating that away. And I think it's particularly important to measure toil, because when it is left unchecked, it can grow exponentially with your service. So what you'll find is that if you don't keep your toil in check, if you don't keep your manual work in check, it will grow to a point where there is no time to automate it away. I've been in this situation where the team I was in knew that we knew the answer to our problems. We knew we needed to automate ourselves out of a job. We knew the answer, but because we had so much toil on our plates at the time, we weren't able to do the right thing. We were just keeping the lights on, but with manual work and manual intervention. And that's the scenario that you want to prevent. You know, we didn't have time to automate ourselves out of a job because we didn't even have time to eat by the point it got to that time. And within SRE, there's a principle that you should spend less than 50% of your time on toil. And of course, how do you keep that in check? You have to measure it. You have to measure the amount of time that you're spending on toil and making sure that it's not growing to an uncontrollable and unachievable level. But not all toil is equal. And this is where we come back to the human side of it. Now, if we have to staff humans to do the work, we're feeding the machines with the blood, sweat, and tears of human beings. I really love this quote because it really summarizes the worst case scenario of the situation you can get into, where it's human energy and human expense to keep the lights on for a system, and that's not what you want. And I define this toil slightly differently as toxic toil. This is the stuff that wakes you up at night, ruins your evenings and weekends, interrupts your work, distracts you, stresses you out. And this is the stuff that you really need to measure and really need to keep an eye on. So I realize I'm a bit low on time, so I'm going to flip ahead slightly to my final hypothesis, which is actually by measuring toil, you are looking after those fundamental human needs of your team, their physiological needs. Are they getting enough sleep? Their safety and security needs. Do they feel like they're safe to fail? Do they feel like they'll be punished to fail? Do they have a sense of belonging and self-esteem? Are they able to do that more interesting engineering work to automate themselves out of a job? And do they have enough time to be continuously learning and improving themselves? They won't have that time if they are overwhelmed with toil in their job. So I'll wrap up now with a couple of final thoughts. At the beginning, I asked, is SRE good for you? And obviously, I have an opinion on this. I think it is. I think the teams that adopt these practices can use them to be happy, healthier, and more sustainable, better places to work. But I would love to hear your experiences too. What have been some of the challenges adopting these practices? Are you just starting out on your journey? Do you need advice? I would love to hear your stories about it. What's worked for you? What hasn't? How did you create that blameless culture in your organization? Or do you need help creating that? Really appreciate everyone's time today and your patience with my coughing throughout. Sorry about that.